Hey everybody, let's talk about domain and range real quick. We've seen this a couple times, but here's kind of the details on it. Here are a series of ordered pairs um, where they give us an X value and a Y value for these things. If X is equal to 1, Y is equal to 2, and we could plot all these points and see what they do. Um, Here is come over 1, and then we're going to go up 2, which would be about there, and there's a point, and 2, 4 would be up here somewhere, and you get a point, and 3, 6 would be about here, and 4. You get the idea, right? They're making a nice straight line. Um, we could find a function that fits those that would do something like that, and we very well would be interested in what is the domain of this and what is the range. Well, I'm clearly putting in these numbers, 1, 2, 3, 4, 5. So those are certainly in the domain. Those are numbers that we put in there and ran through our little machine. The numbers of the range are the ones we get out. So 2, 4, 6, 8, 10 are certainly in the range. And we could put those down there. But the domain and the range are not so much as what we actually put in, they're what we could put in. What possible numbers could I use here? And like you see, if I put a 0, everything's kind of doubling here, right? So 1 multiplied by 2, you get 2. 2 times 2 would be 4. That's our function. So we could write a little expression here that the function that we're dealing with here looks like it's just 2x. Take whatever you plug in, 5, multiply by 2, you get 10. So the question is not what numbers did we put in there, but what can we put in there? And I could certainly put 0, and I could certainly put -1 in there. That's not going to break this function. It's not going to mess anything up mathematically, and I would get all these other points over here. And I could keep going this way, and I could keep going this way, and that's going to give me numbers that go higher and higher, or if I'm on the negative side of this, lower and lower. So the domain is really all the numbers that it's okay to put in there. And in this case, it would be everything from negative infinity to positive infinity. Okay. I could put negative 10,000 in here and multiply that by 2, and I would get negative 20,000. Okay. It didn't break anything, right? I could put positive 43 million, whatever you want to do. Anything between negative infinity and positive infinity is okay to put into that function. And the numbers that I get out would be the range. And if I put a very uh, large negative number, small number, I don't know how you want to say that, close to negative infinity, then um, I'm going to get a range that's down there at negative infinity. And it's going to climb, climb, climb all the way up to positive infinity. So, that's my range. I can put anything into this. I could put 3 and 7/8 in there if I wanted to, and I would get a number out of that. Okay, nothing breaks it here, so it's the all real numbers for the domain, all real numbers for the range, and that's kind of the normal thing. There are some things that we want to avoid though, and so that's worth talking about. Now, we looked at these last time, and we said that the constant function here looks like this, that it's just going to go forever. Okay, so all of these x's could go into it, and all of these y's could come out of it. So my domain is going to be negative infinity to positive infinity, and we could just write r. Let that stand for the set of real numbers. Any number I want to plug into this thing is going to work. The range, meanwhile, are the numbers that come out of that. And in this case, the only number that I ever get out is 2. So it's a kind of small set there. And that's the only number that I get out. Okay. So maybe an equals there. The range would be equal to this to two. That's the only thing that works. This is like what we saw just a minute ago, that linear equation. And this one was a special class of the linear equation, if you remember. Um, this was the identity, where it climbs at 45 degrees and stuff. Um, but when we think about that, we just did this one. All right. Someone just put an R here, double type R for the domain. I can put anything into it. I can get anything out. We just did that one. Looking down here, this was the absolute value function that we saw last time. And what can I put in there? Looks like anything along the horizontal axis. We're actually up here, maybe, but I could put negative 43,280, whatever, right? I could put positive 752. I could keep going zeros in there. So for the domain, all real numbers. But what about the range? I never get anything down here. So my range is restricted this time, and it would be everything from zero up to infinity. I never get anything below zero, and it goes up. Now, looks like I actually do get zero. If I put zero right there and take the absolute value of zero, that would be zero. So zero is included. And for this one, I really should put a hard bracket right there because it's zero, including zero and everything all the way up. This just keeps going up, 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 up. All right. Looks like this is going to be the same thing here. I could put anything on the x-axis I want into this. This is a quadratic, so we recognize that as some kind of version of y equals x squared. And you can see I can put any number in there. I can put all the positive numbers. I can put zero. I can put all the negative numbers and square anything I want to. So the domain is going to be all real numbers. But the range here, again, like the absolute value function, I don't have anything in the southern hemisphere here. So it's going to be zero all the way up to positive infinity. Anything above the this way is possible to get out of that thing. These two tails just keep going up forever. Right here. What do we got? Now, this one was a little bit interesting. This was what we called the reciprocal function. And it had the form of y equals 1 over x. Now, there is a number that I cannot put into this. Do you see it? Do you know what it would be? The number that I do not want, can't put x equal 0 in there. If I did, that would be 1 divided by 0, and that's undefined. Okay. Look what happens right there at x equals 0. See how this thing just goes, if I'm coming from the right-hand side, approaching it from the right, moving left, if you will. This thing just keeps going up and up and up. It keeps getting closer and closer to x equals 0, but I never really get there. Meanwhile, on the other side, it goes down, down, down. But again, I can't put 0 in there. There's a hole right there. So when I think about the domain, I've got to indicate that that one doesn't work. I'll just put D here. I can go all the way from negative infinity up to 0, but not include 0. So soft bracket there. And then I could union that with everything from 0, but not 0 itself, up to positive infinity. I can put anything in there except for that one number. That one number breaks it. And I don't want to break this function. It's a nice machine. I don't want to throw a big rock in it that's going to destroy it. Putting a 0 in there is going to break it. So we don't do that. On the reciprocal squared down here at the bottom, same thing. I can put anything into that function, and just wish I could find where am I? Here we go. Here we go. Got it. Reciprocal squared. Every drawing program I've ever had, they gave you a nice cursor that you can find. This is this little bitty point that you can barely see. Reciprocal squared. Um, I can put in all my negative numbers. I can put in all my positive numbers, but again, there's a hole right there that I cannot put in. So that's going to have the same domain that I have here. And that's not a negative D, that's just a D. The domain is going to be everything from negative infinity up to zero, but not zero. And join that with the set of numbers from zero up to infinity, like that. The range here, this is looking pretty familiar. There's nothing on the bottom, right? So it's everything on the top half, but actually not zero. Remember we said this just keeps getting closer and closer to y equals zero, gets lower and lower, but it never really gets there. So here we'd have to say that the range is zero to infinity, does not include zero. We never actually get to infinity, so it would look like that. We didn't do the range here. Um, this one is going to be everything below the axis, everything above the x-axis, but not the x-axis itself. So again, we've got a hole right there. I cannot run this machine y equals 1 over x and ever get a zero out of it. There's no number that would deliver a zero there. So I should have put that somewhere. Let's put it right here. It's going to look exactly like the other thing. I can go from negative infinity all the way up to zero, but not zero, and all the way zero to infinity. But there's that hole right there. Here is the cubed function, and it would look something like y equals x cubed. Might have a couple numbers dressing it up, moving it around and everything. But when that thing goes zoop like that, I could put this number in, this number, this number. I could keep going this way. I could come up here, and 8 cubed is not on my graph, but I can put that number in, right? 8 times 8 times 8, whatever that is. I don't even know. 64 times 8, 480, and some more. 512 maybe. I don't know. So, all of these numbers that just because they're not on my picture doesn't mean they don't work. The domain here is going to be all real numbers. And this goes all the way down to negative infinity through zero, all the way up to positive infinity. So the range is also all real numbers. You got the idea how this works? It's not hard. It's just, thinking about which ones we could put in. We said this was the square root function. And so with that one, we had something like y equals the square root of some stuff, right? Now, we know something about square roots, right? I can take a square root of all the positive numbers. I can take the square root of zero, but I cannot take the square root of anything below there. So the domain here is going to be 0 to infinity, including 0. I can put 0 in there, and that doesn't break anything. As soon as you try to put -1 in there, take the square root of -1, you're not going to get a real number. So we don't want to include that. The range, though, it's going to start here at 0. Y equals 0 is going to go up to y equals 1, y equals 2, y equals 4. As I put bigger elements of the domain in, I'm going to get bigger elements of the range. So that can go all the way up to infinity like that. Got the last one here. This is the cube root. And again, it's going to be something like y equals the cube root of x. Okay. And could have some other stuff, but it's going to cut in here like that. And I think you can already see that anything can go into that function, and anything can be brought out of that. If I take the cube root of 43, I'm up somewhere around 6.4 or something. I don't know. So it's going to get bigger and bigger. The cube root of 1,000 is 10. The cube root of 43 million. It's just going to get bigger and bigger. And same thing on the negative side. Cube root of zero is zero, so he's in the club, you know. Um, so that's just all those functions that we saw before. A, we get to see them again. B, now we're thinking about what can I put in there and what's going to break it. We kind of saw two things that broke that were bad, right? Um, right here on the square roots, we don't want no negative numbers or square roots, in square roots, whatever you want to call that. Okay. That will break the square root function. And then over here, where'd it go? Um, oh, yeah. We said that in the reciprocal and therefore also the reciprocal squared function that I don't want a zero in the denominator. So that's another bad. No zero downstairs in denominator. Okay. Those are kind of the two big things that you have to worry about. And those, as long as you stay clear of those, then everybody else has got a full access to, you know, all real numbers. And that's kind of the big question here. Can I put all the numbers in it or not? And those were the two that we broke. And so those are the ones we got to watch out for. So here are some examples of functions. And, the question is, well, what numbers can I put in there? And the answer here, I got to look for, make sure that I no square roots of negative numbers. Okay. So I look through my thing and say, there's no square roots at all. I'm okay there. Right. And then I also want to make sure that there's no zeros. There's no way to get a zero in the denominator. Don't divide by zero. Okay, that'd be a better way to say that. Well, I'm not dividing by anything. Okay, so again, here, this one I can put anything into the domain that I want. And for the range, I'm going to get any possible number out. Now, you'd have to kind of scratch your head about that, but clearly, if I put, say zero in here, I get five. And if I put 15 in here, that's going to be 225. And that would make this 450, and five minus 450 is a pretty big negative number. Okay. Um, but it didn't break it, right? Now, there's actually a top cap on this thing. If we were to draw this, um, what we're going to have is this is going to make a parabola, 2x squared, and it's upside down. We're going to learn more about this later on, but that negative there flips it upside down, and then we're adding 5 to it. So the normal parabola would look like this, and when we multiply it by 2, it's going to squish it in a little bit. But when we multiply by a negative number, it's going to invert it. It's going to flip it upside down. And we're still not done. Now we've got to add 5 to it. So everything's 5 higher than that. We're going to get a parabola something like that. Okay. So this isn't exactly right. What's going to happen is my biggest y value, the biggest element of the range is going to be that 5 right there. At that point, when I put a 0 in there, I get 5 out. And anything bigger or smaller, any other number, if I put 1 in here, that's going to bring it down, right? That 1 squared would be 1 times -2 would be -2. 5 -2 would be a 3, right? So now I'm down to here. I'm coming down on both sides. Put a -1 in here. Square, that's a +1 times -2 would be -2. Take it away, 3. And you can see that I'm just going to ride this hill all the way down right there. That 0, 5 is the highest point. So for my range, I can go from -infinity all the way up to 5, including 5, and that would be my range right there. Okay. I guess we're kind of more interested in the domain coming out of these, but it's kind of good to think about the range too. This next one, same deal, right? Now this one does not have a square. There's no cube. There's no cube roots. There's no square roots. We're not dividing by anything. So this is going to be a linear function. In fact, we could straighten this out a little bit. Everything in here, nothing inside the parentheses will combine. So we could take the parentheses away and just have 4 minus 3x, put that plus 7. Now I've got a couple numbers that could go together. If you wanted to flip it around, negative 3x plus 11, that's just a nice straight line. That's a linear function, okay? You can see the mx plus b right there, form of it if you want, right? And if you want to feel a little warm, fuzzy feeling, you can put the y back in and think about it like that. But that's a linear function. It's going to give us a nice straight line. Um, the y-intercept is there at 11, so I'll put a dot up here. The slope is negative 3. I'm going to go down 3 over 1, down 3 over 1. You know, something, I don't have this to scale, but you get the idea, right? Something like that. And I'm looking, this thing could just keep going and going, and my x would get bigger and bigger, my y would get smaller and smaller. And then over here, I could keep going to the left. And so my x could keep getting smaller and smaller. My y could keep getting bigger and bigger. The domain here is going to be all real numbers, and I can get all real numbers out of this thing. And there's no top cap on it like we had here in the range. This just is everything. Number 3, though, I think you can already see some problems, right? We were looking for these two things here. I want to check that there are no square roots of negative numbers, and I want to check that there's no zeros in the denominator. I think you can already see that this one could potentially break both of those. All right, let's do the denominator first. That's probably a little bit easier. When I look at that denominator, I don't ever want that whole denominator to be equal to 0. So the easiest thing to do is say, well, if I just take that x minus 4 and set it equal to 0, then what would break it? All right, and you can see I could add 4. I don't ever, ever, ever want x to be equal to 4. That's bad. That would give us a 0 in the denominator and break our function here. Okay, so that is outside of the domain. Okay, let's see if there's anything else that we need to leave out. And I'm going to check the other rule here. The square root should never be negative. I need that stuff underneath the radical to be greater than 0, like that. Okay. If I subtract 4 here, you can see that x needs to be greater than negative 4. What happens if I put a negative 5 in here? Negative 5 plus 4, that's negative 1. I'm trying to take the square root of this stuff, square root of negative 1. See how that breaks it right there? Negative 2 would break it. Negative 10 would break it. Negative 63,000 would break it. So um, anything below here is out. X less than or equal to negative 4 is bad. All right, so these are the two that we don't want. Okay, and as such, then what I need to do is get a little bit tricky here and come down here and say, I can go from negative infinity. No, I'm sorry, wrong game. So for the domain, I got to be greater than 4. That's the smallest thing that I can put in there. And because that's not a greater than or equal to, I don't quite ever get negative 4. So I'm going to put a negative 4 here with a soft bracket. It's got to be greater than negative 4. And then it's going to go up to, I also have to make sure that this gets left out. So I'm going to go up to 4, but I don't want to include 4. And then I can start over again and say, okay, everything from 4 to infinity is fine, like that. but there's a couple problems in there. And when I think about the domain, what numbers can I put into this without breaking it, knowing that there's kind of two things that will break it, you know, then those are the values that I can put in there. We could do the range. I'm not really worried about that. If I put a -4 in there, this would be a 0, and that would be a -8. So I'm going to get a 0 there. If I go all the way to 4 on the top, I'd have the square root of 8, which is 2.8 or something like that. But here, that 4 minus 4 would be 0. So it's going to get, this is essentially a reciprocal function. It's a square root function and a reciprocal function at the same time. This might be worth drawing a little picture of here. Dragging out my calculator and putting this thing in here, y equals, we'll clear this out. On the top, I've got a square root x minus 4. And you know what? We could just look at that much of it right there. Okay. Um, and that was that, remember we said x had to be greater. Did I type that in right? What did I put? Oh, I need an x plus 4 there. All right. Thought I was going crazy. All right, so here is that. Remember we said that x had to be greater than -4. So right there is -4. -4 is okay, because that would just give me a 0. But everything to the right of that works. Right there. There's the square root function. This is kind of two functions in one. There's the top function, and then on the bottom we've got a reciprocal function. What would that part look like? I go back and say, let's clear this out. And if I just had 1 divided by, what was it, x minus 4, I'm going to put that in parentheses so I can see what that much looks like. There's one of those reciprocal functions right there. It got shifted over because of that -4 in there. And again, we'll talk more about that. But it goes down, 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 down to negative infinity, jumps up here to positive infinity, comes back down like that. Sometimes you see in the doctor shows on TV, there's a heartbeat thing. It kind of looks like that. All right, but that's kind of one, taking each piece independently. What we actually have is both of those at the same time. So on top, I want the square root of x plus 4. Try to get it right this time. Close off the square root, and then I'm dividing by parenthesis x minus 4. And when I graph that, I get that right there. Okay. So, this is kind of an odd one, but you can see right here that, my range, that I'm going from negative infinity up to 0, and that's that 0 that we got right there, right? And but that's going to be my top value. But I never really get there. This is sliding off, getting closer and closer, but I actually never get there. Same thing on the other side. And then here in the middle where it jumps, this is a problem with the calculator. It says, give me some points and then just draw a line between them. So it's drawing that line there, but it's not actually there, if that makes sense. So when we came down here, this is not a number. So I need to go from negative infinity up to 0 and join that with 0 to positive infinity like that. Anyway, domain and range. Here's kind of a strange function that I don't know why they slid it into this section, but it needed to go somewhere. Every time you pay your phone bill or anything else, there's a certain amount that they charge you for having an account. Here, I just picked $25. And then the more you use, the more they charge you, right? So I've got $3 for every kilowatt hour over 10, you get the first 10 for free. That's included in the monthly account payment. But, you know, um, I could make a little table here if I wanted to. No matter what, I got to pay $25. So if I don't use any electricity, but I still got service, I got to pay the 25. If I use one or two or three all the way up to 10, then it's still 25. But as soon as I hit 11, now it's going to jump. I got to pay $3 more because I used more data, right? So that would be 28, and 12, would be another three. So that's 31. And it's going to keep going like that, forever, as much as I use. When I graph that thing, um, 0 all the way up to 10 here, that's just going to be a constant function of $25. So I'm going to start right there and I'm going to go across. And I haven't exceeded how much they give me, quote, for free, right? It's not really free, it's built in. All right. But that's the that's the first part. Now, as soon as I use that 11th kilowatt hour, now it's going to jump up to 28. And then when I use the 12th one, it jumps up to 31 and 34 and 37. Okay. So that's kind of a funny looking function. It's a piecewise function. For this piece of it, it's only $25, and for this piece, it's 28. You know, it doesn't matter if I use 12.2 or 12.6 or 12.8. It's 31 until I get to 13. Okay, so that's a kind of weird function. Domain range. Um, I suppose you could probably start this one at 0. I don't know how you're going to use negative electricity. Actually, now that they've deregulated power, you can actually generate your own power if you have solar panels on your house, if you have wind turbines. You could go buy an old train locomotive, set it up in your yard and run it, generate electricity with it, and sell that back to the company. Okay. But let's pretend like you're not making electricity and selling it. I would probably start this at 0 for most customers. Um, everybody's starting out here at X equals 0. How much energy did you use? 0. Okay. But then you could go all the way up to infinity like that. So domains like that. The range, the least you can possibly pay is $25, including $25. And it would go all the way up to infinity. All right. And with this cold snap, our electric bills might go up to infinity. So watch out. Here are all those functions one more time. And, that might not be a bad screenshot, just so you kind of had them somewhere. It'd be nice if the graphs were there, but you know what the graphs are there. Your calculator knows what they look like and stuff. So, kind of get to know these main functions. Think about how they work together, like that one where we had a square root on the top and a reciprocal on the bottom and stuff. Um, they'll become good friends, and you'll recognize them. I didn't have a graphing calculator when I went through school, so we kind of had to know these things, but now it's easy enough to just push some buttons, and maybe too easy, I don't know. But they're your friends. All right, thanks, and have a great day.